Okay, from the previous lecture, we can estimate the unit graphs. Okay, we can, and the next we use this to apply this unit graph to find the direct runoff and stream flow graphs. Okay, so for the new rainfall, for a new rainfall hydrographs, we can subtract the infiltration or loss from this rainfall to get the excess rainfall hydrograph, and use this to calculate the from the previous lecture, and can you use the excess rainfall hydrograph to combine with the unit hydrograph to find the stream flow hydrograph. Okay, we use the discrete convolution equation. So based on the same equation, in this now we know the u. We know u, and given new p, so we can estimate the qn. So we can estimate qn is the direct runoff hydrograph, and by adding estimate the bed flow to the direct runoff hydrograph, so we can finally we can estimate the stream flow hydrograph. Okay. For example, the example, calculate the stream flow hydrograph for the 6-inch excess rainfall, 2 inch in the first half hour, 3 inch in the second half, and 1 inch in the third half hour. So it means time step itself, half hour. And using half hour unit graph from the previous example, and assume the bed flow is the constant of the 500 cubic foot per second throughout the flood, and check the depth of the direct runoff is equal to the total excess precipitation. And for the watershed area, it's the same as the previous example. Okay. So we use the method of convolution to from this is table from the previous table, show in the below table. And we can start from we can estimate the number of the q. Okay, based on this equation, n plus m subtract 1, so we got 11. So q is equal to q1 to q11. We start from q1. q1 is p1 times u1, so we know u1, and given new is p1, we can estimate q1. And for q2 is p2 u1 plus p1 u2, is based on the series of the equation of discrete convolution, and q3. Okay, p3 u1, p2 u2, and p1 u3. Okay, and we can put together in this equation, in the table. Let's say that this one is from p1 u1, so we get AO, and this one p1 u2. Okay, and this is p2 u1, and this one p1 u3, p2 u2, and p3 u1. Okay, so that is like the make a couple between the p. This is p1, p2, p3, and this is u1, u2, u3 until u9. Okay, once we finish to write the series of the pu, so next we sum each row to get the direct runoff. Okay, and sum together for every time step. So we got the total is 11 time steps. So we got 58,000 cubic meter per second. And the next we check the depth of the flow. So from the 54,000 multiplied by time step. Okay, 0.5 times the 3,600. Okay, so we got the volume of the flow is the 8.8, 9.8, 10 power 7 cubic feet. We divided by area is 1.9610 power 8 square feet. So we got 0.5 feet or 6 inch. So it's equal to excess rainfall. So it's okay. So our solution is correct. Okay. And the last step, we add the Lect with the base flow is and 5,000. So we got the final column is the stream flow, say, plus the 500 cubic per second. If we put together in the term of graph, we got like this. Okay, for this is for the 1 inch. The first is 2 inch. The third inch and 1 inch. Okay, and the order is incorrect. Okay, so we got this for the third inch, this part. Okay, for the third inch, and this part for the base flow. Okay, so put make a summation. So we got the stream flow hydrographs. Okay. Okay, the next case, if the unit hydrograph is unique for the area and for the rainfall. For example, if you have unit hydrograph for point A, this one for point A, so we have this is unit hydrograph for point A. Okay, we can, but if we can't use this unit hydrograph for point C or point B or point C. Point B is somewhere else on the same catchment. We can bring the unit hydrograph at point B to use as a point C, or we can bring the unit hydrograph at point A to nearby the subcatchment at point C. So if we want to construct the unit hydrograph for point B and C from different locations, we have to use this method we call the synthetic unit hydrograph to develop the unit hydrograph. The basic idea of this is we can construct the shape of unit hydrograph using, for example, this method. We can estimate this the Q peak and time to peak and rainfall to estimate. We use standard shape of the unit hydrograph, or we can use the require another shape. We define Q peak, time to peak up from the central of the rainfall, and estimated base time of the unit hydrograph and the shape of unit hydrograph. So we can, for point B and C, we have to use the synthetic unit hydrograph to construct the hydrographs. To construct unit hydrographs.